Okay, let's look at some ionic bonding. First, the vocabulary. An ion is an atom with a charge. Okay, so either it has extra protons or extra electrons, because remember, every proton gives a +1 charge. Every electron gives a -1 charge. So if they're not balanced, if it's not neutral, you have a charge, an ion. A cation is a positively charged atom. That means there's more protons than electrons. An anion is a negatively charged ion. There's more electrons than protons. So when you have a positive and a negative ion coming together, you get an ionic bond. Typically, it's a metal and a nonmetal. Which are the metals? Let's look at the periodic table here. This is color-coded for you. So notice everything to the left of this little stair step is a metal. All the ones colored red. Hydrogen is not a metal for this purpose. Notice it's blue. It's color-coded with the nonmetals. And these in-betweens here that are yellow, this is the metalloids. Sometimes they act like metals, sometimes they act like nonmetals. Okay? But all the red here, this is all metals, most of the periodic table. And all the blue are the nonmetals on the right, plus hydrogen. Okay, let's look at some examples. Here is sodium and chlorine. When they bond together, a metal and a nonmetal, you're going to get an ionic bond. Okay, first we need to know the charge. And you can figure that out by looking at the periodic table. The exclusion is the transition metals, the ones in between here. It's column 3 to 12. Those don't have a set charge. There's different possibilities. It's column 1, it's going to have a +1 charge. Column 2, when it bonds, it gets a +2. Over here, column 13 is going to be 3+. Column 14 can be plus or minus depending on if it's a metal or a non-metal. Okay. 15, it's going to be 3 minus. 16, 2 minus. 17, 1 minus. Let's take a look. Okay, the charges are right here. This is the pattern. Again, it's 1 plus, 2 plus. Skip the transition metals. 3 plus, 4. Then you have 3 minus, 2 minus, 1 minus. And finally, you have the noble gases that don't have a charge because they don't bond. So now that we know the charges, here's sodium, and it's in this column right here, so there's a +1. Here's chlorine, and it's in this column, so it has a -1. Okay? So +1 and -1, those balance out. You don't have to do any balancing because it's just +1 and -1. You get NaCl. Now to name an ionic bond, first you write the name of the metal out. In this case, it's sodium. And then you write the nonmetal and you change the ending to "ide", I-D-E. So you get sodium chloride. You can see how I check that out. Okay, sodium had a +1, chlorine had a -1. So 1 on the metal side, 1 on the non-metal side, right? A +1 and a -1, that's balanced out. You only needed 1 of each, so sodium chloride. Let's look at one that's a little bit different. Calcium and nitrogen. When they bond together, let's see what happens. Calcium is in this column, so it has a 2+ charge when it bonds. Nitrogen is in this column, so it has a 3- charge when it bonds. Well, 2+ and 3- do not equal 0, so we're going to have to balance it a little bit. Okay. So each calcium is a 2+, each nitrogen is a 3-. Okay, to start off, we have 2+ and 3-. That's not balanced. There's more charge on the nitrogen side, right? 3 is higher than 2. So if we add another calcium, 2 plus 2 is 4. That's now 2 calciums for every 1 nitrogen. Still not balanced, right? Because now it's 4 versus 3. Now the calcium side is higher. So let's add a nitrogen. 3 plus an additional 3 is 6. Now it's 4 versus 6. Now the nitrogen side is higher again. Let's add another calcium. So plus 2 again. So 2 plus 2 plus 2, 6. So now we have 6 positive charge, 6 negative charge, and that's balanced. Okay. How many did it take of each side? Well, it took 3 calciums to get to 6, and it took 2 nitrogens to get to 6. We just kept going until they're balanced. So that looks like 3 calciums, 2 nitrogens. This is our ratio right here, Ca3N2 for calcium nitride.